Hello, this is Mrs. Schroeder. Welcome back to chemistry, where we're learning how to name ionic compounds. Now, in my last video we talked about naming binary compounds. Today we're going to talk about polyatomic ions and also things that involve a variable charge. So I'm going to skip through a couple slides to get to our polyatomic ions. Now, you had a list of polyatomic ions that we're going to use on a test you'd be allowed to use, but you did have some that you had to memorize, and again, if you did not do well, go back and practice those. But a polyatomic ion is basically a charged group of two or more covalently bonded atoms, but they act as a single unit because they have a charge. So in this chapter, we're going to worry just about the charge that they have. Later on, we'll learn about how they're bonded. But for now, just remember it's got a charge, and I can look that charge up. Polyatomic ions, the SO4 has a 2-, SO3 also has a 2-. That means it has 2 extra electrons that somehow it stole. And pay attention to these names. There's an 8 and there's an ite. Anytime you see 8 or ite at the end of a name, that means it's a polyatomic ion. That's different than sulfide with the IDE, which means S2-. So our ion names are very important. You have to pay a lot of attention to it. There is a table in your book. Again, you have the sheet I gave out. Naming them is not much different than naming our binary compounds. We're going to name the cation first, the anion second, just in the order that we see it. So, for example, my Na2CO3, Na is sodium, and CO3, I recognize that because I've started to use my polyatomic ion list and understand what the names are. Recognize the easy ones. That's your carbonate. So the name of this is simply sodium carbonate. You recognize your polyatomic ion here. PO4 is your polyatomic ion, so I would name this as aluminum. And then phosphate. Okay, the next one, magnesium sulfate, ammonium, there's your nitrate. So start to recognize where your polyatomic ions are. And that's the only hard part about naming these, is recognizing the polyatomic ion, practicing with the names. When I have to figure out the formula, it's, again, very similar as binary formulas. I'm going to do the AX plus BY equals 0, the charge and the number, charge and the number. But in this case, I'm going to use parentheses if I have a subscript, because if I have something like SO4 and I needed 2 of them, if I just wrote 2 of them, it looks like SO4 or SO42. If I need 2 of them, I'm going to write it as SO42 with the parentheses around it, so you can clearly see that there's 2 of these ions, not 42 oxygens. So when I do these, my polyatomic ions, my sodium, again, recognize it's got a +1 charge, and it's Na. Acetate has a -1 charge. It's C2H3O. So +1 and a -1 balance out, and that one's going to be equal. So nothing further is needed. Sorry, O2. Okay, the next one is the cesium thiocyanate. So cesium, when you look that up and figure out the charge on cesium, it's a +1. CS. Thiosulfate. Thio is a term that means has sulfur in it. S2O3. Some of these I don't have memorized either. This one has a -2 charge on it. So in order to balance my cesium with a 1 and my thiocyanate with a 2, I have to add another one of these. So I have to have 2 cesium CS2 S2O3. Okay. Do one more. Strontium has a +2 charge. Cyanide is Cn with a -1 charge. In order to make this -1 cancel the -2, I need 2 of them. And I put my parentheses around here so that my 2 clearly means it's 2 of the entire thing. Now, we're going to move on next to metals with a variable charge. Your transition metals, and some of those in groups 13 and 14 and 15 that can have variable charges. These are ones that the charge could be a 2, it could be a 4, it might be a 3 or a 1. So I have to indicate the charge the same as how we named them, the charge with the Roman numerals after the metal ion. So, example, when I'm given a name, notice how the charge is given right here. This tells me I'm using copper with the 1, not copper 2 or not copper 3, but copper with a +1 charge on it. Chlorine, look it up on your periodic table. It's got a -1. So I'd write that as CuCl. Okay. Again, it's telling me it's got a +3 on the chromium. Sulfur has an IDE, so I would look that up, and sulfur has a -2 charge on it. The only way to balance that is I have 2 of those and 3 of those. Now notice, my 2 here is not the same as that. A lot of people think that if they see a 3, they're going to automatically put a 3 as a subscript. Remember, the 3 is the charge. 3 is the charge. Balance the charges equal to 0. AX plus BY has to equal 0. In this case, I have a charge of +3, and there's 2 of them, plus a charge of -2, and there's 3 of them. So 6 minus 6 equals 0, which works out. If I had put the 3 here, instead it would not have balanced my charges to 0. Alright, continuing on. When we have a transition metal, but I don't know the charge on it, this is where it gets hard and it gets tricky. In this case, you have to first recognize that you don't know it. Okay? Now you have to figure out what the charge is. So this is the hard part that people get stuck on. Make sure you write this down. The charge will then go in the Roman numerals after the name once I figure it out. So MnBr2, I know this is manganese. I know it's a transition element, so I'm going to put the parentheses. Br2 is bromide. Now I have to figure out the charge. If this one is X, I don't know what it is. And this one is a -1. In this case, I'm going to have X plus 2 times a -1 equals 0. So X has to equal 2. This 2 is what goes in the parentheses. The next one, Fen. Fe is iron. Again, recognize that's a transition element. N is nitrogen, which is nitride. And I look at my charges. Nitrogen has a -3. This I don't know. So X plus a -3 has to equal 0, which tells you, again, that this X has to equal 3. 1, 2, 3 is what goes in here. This 3 is what goes in here. Try one more for you. Oxygen has a -2 charge on it. Lead, you don't know. So we're going to call this lead something oxide. So when I do my calculation, X plus, there's 2 of the -2 charges has to equal 0. Therefore, X equals 4. So I put a 4 in my parentheses. The other ones are the same idea. We'll do these in class. These include polyatomic ions. As long as I know my charge, I'm going to do the same thing here. And that's all we have for now. So go back, review your notes, practice those couple problems, see if you can get them right so that when we go through them in class, if you have questions, you'll understand what questions you have to ask on how to name these things.